Hi, I've only just started doing Paul McWhorter's AI on the Edge lessons because I've been having problems with my Raspberry Pi 5, but hopefully that's all sorted out. Now, I didn't buy the Sunfounder AI Fusion Lab Kit, I think it's called. It was too expensive for me, but I did buy the Fusion hat itself. And I'm pretty impressed with it because it's well, anyone who has one will know it's got the connectors for the motors. That you don't have to have chips, an extra chip to do ADC. You've got an on-off button. You've got a battery, so it's perfect for putting in a robot. So I love the hardware, but I'm not so impressed with the software. Now, Paul said that to do these lessons, we really ought to download the custom OS from Sunfounder, and then don't touch it. You don't upgrade it. You don't update it because otherwise things will go horrendously wrong. And they've also disabled being able to install anything on it, which is a problem for something I want to do, but perhaps it won't be a problem to you. And you also, I only found this out recently, you cannot use this this Fusion hat package like that unless you've got a Fusion hat itself, and I don't find that unreasonable because Sunfounder are sponsoring the lessons. They're paying Paul to make the lessons, and why should people be able to do the lessons without buying something from Sunfounder? But what I do have a problem with is their library has, well, I don't know whether it's all rather lame, but some of it is rather lame. Now, if you look at the top line up there, import pin and pin mode, and then down here you say the pin's 5, and then you go this pin, and then you use the pin number, and the mode equals whatever. Now that looks incredibly like it's based on rpi.gpio, which I stopped using ages and ages ago when I was using my Raspberry Pi 3, I think, because it isn't that great. Now, if you look at this, if you want to blink your LED, you put it high, you put it in a loop, you put it high, you put it, you sleep, you put it low, you sleep. That blocks. It works, but it blocks. So if you use GPIO 0, like here, now GPIO 0 is written by the Raspberry Pi org themselves. I don't know, it's been around at least 8 years, I would reckon, and it's got so much in it, so you, instead of importing the pin and doing everything yourself, you go import LED and you just declare it's an LED, and it's got lots of functionality, so you can just go blink. And the best thing about it is it doesn't block. So if you run that, there, it printed hello, so it isn't blocking. So that's great. Now if you want to see more about it, if you go in the shell, import GPIO 0, and then you can, whenever I want to find out about something, I just go dir on it, there, and it will tell you lots about what you can do with it. Like it always confuses me because it isn't in alphabetical order. It's uppercase come before lowercase, which can confuse a stupid person. So you've got button, you've got device, you've got LED, you've got LED bar graph, you've got PWM LED, you've got, well, more things that you can shake a stick at, really. RGB LED, so all very useful. And you, did I say you can go help on that, but that gives you masses of stuff, so it's too difficult. But if you want things more to do with your LED, there, that's better. So as opposed to you have to do everything manually, you've got on, off, blink, close, toggle, lots of wonderful things. So that's what I've been using for my programs. I'm going to demonstrate 4 programs after at the end of this video. I will put in times for when they start and stop, so you don't have to watch the whole lot if you don't want to. I've lost track of what I was saying. Yes, so I've been using RPIO0 in these programs, and you can get round. You don't have to use threading. Well, you have to use threading for some things, but where Paul was wanting to blink, he had to use threading. And why bother? So if you want to know more about it, I think I did do a video, but I can't find it. Right, this is GPIO0, read the docs, blah blah, and installing. Not you have to, because it's installed automatically. So if you go into basic recipes, it tells you all sorts of things. Pin numbering is GPIO, not physical. LED, button, you've got servo, you've got potentiometer, you've got an LED bar graph, you've got motor, you've got you've got an RGB LED, light sensor. Everything is taken care of. Well, not everything, obviously. And robot. So it's great. And there's another thing that where is it? Right, this I only found about this morning. Source values. Right, GPIO0 provides a method of using a declarative programming paradigm to connect devices together. Well, who wants to read that? So if you just look at this, you're using GPIO0 and you import LED and button, you declare your button, and then you can just say le.source equals button, which means the value of the button goes to your LED. What could be more simple than that? They've deliberately made it so all the values of things go from 0 to 1, so everything is compatible, and that is equivalent to that. But that is blocking. So you've got a loop, and you say, right, I want that value to be that value, please. Sleep, sleep, sleep. So that the main advantage of using GPIO0 is it just annihilates all your blocking, your code that is blocking things, which is great. So I highly recommend it, and I'm stopping now, and you can watch my solutions to his lessons, some of the lessons. Okay. So this is Paul's program for lesson 9, which was controlling the brightness of an LED using a potentiometer and giving audible feedback of the brightness level. Now the only thing I've changed in this, I think, is that instead of just having from time import sleep, I've just added as ZZZ because it's easier to type. So there are 2 things I don't like about this program. One is I don't like that big swathe of if blah blah blah, because surely if you know what right val is, you can calculate the range yourself from right val. The only complications are the first and the last, if right val is less than 1, you don't want to put your LED is brightness 0, you want to put your LED is off. And equally, the other end, you don't want to put your LED is brightness 11, you want to put your LED is full brightness. But apart from that, you just go 1, 2, 3, 4, 5 brightnesses, etc. And the other thing I don't like is a statement like that. If right val is greater than equal to 1 and right val is less than 10, there's a kind of more elegant way of writing that, and I will show you in my program, which is here. Right, I am still using the from fusionhat.adc import ADC as opposed to using GPIO 0 pot, and it's because I just haven't had time to look at it to see whether it works properly with the Fusion Hat. I've used it before, of course, but I'm not with a Fusion Hat, so I thought I'd just leave that. But I am using PWM LED from the GPIO 0, but apart from that, nothing else is much different. So I'm using Paul's logic. I thought it was easier to completely use the logic. Therefore, if the right val is less than 1, it's saying the range is 0 and the LED is off. And if the right val is greater than equal to 99, the range is 11 and your LED is full brightness. So instead of that swathe of if blah blah is greater than that and less than that and then the range is whatever, you can calculate it just like that. So that line there is the same syntax. Well, no, you can use the same syntax to replace that. So that line there, that's what I didn't like. So you could say if 1 is less than right val is less than 10, if you get my drift. So I'll go back to this one. It isn't exactly the same variables, but you can write that statement in that format, which is great. So you're just dividing it by 10, adding 1 and making it into an integer, and the range comes out exactly as you want it. And then the only other thing is, because I'm using GPIO 0, it expects the values to be between 0 and 1, but apart from that, everything is the same. The logic is the same. So we'll just run this.
Your LED is on.
Your LED is off.
Your LED is brightness 1. Your LED is brightness 2.
Whoops.
Your LED is brightness 3. Your LED is brightness 8. Your LED is full brightness. Your LED is brightness 10. Your LED is brightness 8.
There, as you can see, it works jolly well like the original. So this is Paul's program for lesson 12, when he was showing everyone how to do threading, and I think the only thing I've changed is that, as before. Yep. So we'll run this program, see what happens. Blink time in seconds. It started off at 1, so if we put in 3, on for 3, off for 3, on for 3, off for 3, and we think, oh, we want it a bit faster than that, so it's 0.5. There we go, 0.5, 0.5, 0.5. Then we think, right, okay, let's try 2. So we type in, oh no, I put in 22. Best I change that. So you type, the prompt has come back, so you type 2. Hello, nothing's happening. Hello. And that is because it's doing its on for 22, off for 22, and then it's saying, hello, have you asked me to do anything else? And this is still the off for 22. This is getting boring. And you can even put in 1. You think, come on, 1, why aren't you doing it? Well, it's changed to 2. Oh, now it's changed to 1. That's okay. So, in a way, I think that's almost worse than it just stopping when it's waiting for the prompt. So we'll go quit on that. Now, my version is a lot simpler. I do know how to use threading, but in these circumstances I'm not going to use threading. So I'm using GPIO 0 instead of the Fusion Hat whatever, because it makes everything so simple. Again, my red LED is actually going to be yellow, and all you do is you go input blink time, and then if it's Q you stop, otherwise you just blink. So let's see what happens here. I started it off not blinking, so we will put in 2. Right. And strangely, that there, I'm sure in the past I've just put in red LED dot blink and then the first one, and it defaults to being the same, but it was actually doing on for 2, off for 1, on for 2, off for 1. So that's why I've had to put in the 2 values. Right, so that seems to be working. Right, so if I go 0.5, you don't put in the 0.5 there, do you? You put in the 0.5 there. Right, 0.5, brilliant. Now you go 44, you think, I want 4, but it's gone to 44. Oh no! So you go 1, and it gets it out of it, because it's issued another blink statement, the red LED dot blink. So I think that's pretty good. But it didn't use threading. I'm probably getting all the lessons mixed up, but I think it was at the end of lesson 12 that Paul wanted us to use our voice to change the brightness of an LED. So as before, I'm using GPIO 0 for the PWM LED. Ignore all that for the time being. And here we go. Here's the while true loop. It prompts you to say something, and then if you say quit in the command, you break, which means you just go print quitting and you turn the LED off. Or if you say pulse, it will start pulsing the LED and it will go back up to prompt. So the bit that we're interested in, well I am anyway, is the value. So if you go value 10, hopefully it ought to turn on the LED to 10%, or value 50, 50%, etc. But I will just show you a slight complication. Value 10. If it doesn't recognize it and you go value, it just sets it to 0. Value 10. I'll stop that. Right. You can see that's the command it got, which is value, and then the string of 10. So we have to convert the string of 10 to 10, like that. So back to the program. So, excuse me, what we do, if value is in the command, I just for something else that's taking out the word value, so I have taken out, and so then I split the command up into words, which is what num strings is. It's all the words. It's a list of all the words in there. So then I set my val to 0 to initialize it, and then I go through the words of num strings and say, if the first word is in numbers.keys, which is my dictionary, so there's dictionary, and 10, there's 10, and it says yep, therefore I use the value of 10. All well and good. And which is what that does. It adds 10 to my val. Then it says if my val is 0 or 100, that's a kind of special case. So you've come in there. 0, you've either said 0 or off, and either way you wouldn't want to have another word in there. You wouldn't want 020 or 054, that would be stupid. Or on, that's 100. So you break, because you don't want to look for any more words or any more numbers. That would be stupid. And then it says if my val is greater than 100, you're obviously talking rubbish. And the reason for that is, if you said 50, 60, that is rubbish. I mean, there's an awful lot more rubbish than you can talk, that you can say, but it tries to catch it. So if it's greater than 100, it cannot be a percentage. So down here, we're assuming that everything's fine. You've got a number between 0 and 100. And because I'm using GPIO 0, the values have to be between 0 to 1, which is why I'm dividing by 10. And then I just say the LED is at that percentage and continue. Now, if I don't have anything after value, or is gobbledygook, it just turns the LED off there, so it would be 0. Then if you didn't say value, pulse or quit, it says sorry, I didn't get that, and it goes back up and it looks for what you're saying again. So that's what happened when it was 10. But say you came in and you said 49, it would do the same thing. It will go hello, and it will go, is it in the keys? Well, yes, 40 is, and I won't bother to show you, but 40 is 40. So it adds it to that, and then it goes back and it says, oh, I found a 9 as well, and so that's added to my val, so it's 49, and it goes down there and it turns on the LED, and everything ought to be fine and dandy. So we'll see what happens there. Value 52. Right, value 52, LED at 52. Yep, that all seems perfectly good. Yeah, because I said 50 and 50 and whatever, it caught that there was a value, it caught there was a 50, and that caught there was a, yes, and a 2. Right, I will be quiet, then it will reset. Value off. Value on. Value 50, 60. Value 100. Value, if you just go value like that, it sets it to 0 because it can't understand. Value 54. Value 54. Yep. Pulse. And as you can see, the LED is pulsing. Quit. Now, I can't remember. Did I say 100? Did I say 100? Yes. When I said 100, it actually does work for 100. So if we go up to my jolly old dictionary, 1 is 1, and 100, because I'm only looking for numbers up to 100. It has to be 100. It can't be 200, 300, 400. Therefore, when I put in 100, that's 99, because for a valid number it would have to be 100. So 1 plus 99 is 100, if you get my drift. I mean, if you say total rubbish, then everything will go wrong. But you know, this isn't meant to be hugely well, it's a beginner's little thing, isn't it? So if I run it again, 100. Oh, sorry, should have said value. Value 100. Yeah, value 100 comes out as 99, because you'd never go 100, you'd always go 100. So is that about all I need to say about this? Very probably. Oops, I'm still talking. Quit. There, quit. I think that's about it. This is my solution to the homework that Paul set at the end of lesson number 13. Now, I can't understand why he was using threading at all in lesson number 13, but maybe I'm missing something. I'm going to run quickly through the code. I'm using, as well as RGB LED, I'm also using traffic lights, because I've got a little traffic light module. And then the colour 0 is a dictionary of colours, so it gives you the colour name and then the RGB values. That is for misheard colours, because if I say fuchsia, it thinks it's future. Can't cope with orchid at all. And another way of kind of mending what the computer's hearing is, I've got that, because quite often if I say colour, it thinks I've said Carla or Carlo. And strangely, I am English, and yet if I use language English American, it understands me better than English GB. Strange. Right, so we're at the top and it's prompting, and what it wants is you to say either colour and then a colour, or you could go traffic light red, traffic light green, traffic light amber, traffic light amber and red, or no, red and amber even, and you could also say stop, go, prepare to stop. I think that's about it. So first of all, if it's quit, I quit. The traffic light is just saying if it's red or stop, then you say stop, but it says stop, and you set it to red. And if it's red and amber or prepare to go, it will say prepare to go and set it to red and amber. Amber is prepare to stop, and it says it and sets it to amber. Green is go, it says go and sets it to green. Now I've got that little sleep after each of them, otherwise it will go say what colour. So you want go, and then it goes up to the top of the loop and says say what colour you want, or whatever it says, I can't remember. Now that is just for the traffic light. For the other one, which is colour, so it's detected that you've said colour, and then it looks at the command. You've got rid of the colour bit. It looks at the command and it says, are you in my dictionary of commonly misheard things? So it will replace red with an A to a normal red, which is easy peasy. Now I'm just saying here, if the colour is in named, oh no, I forgot that bit. Now in I might have said cornflower blue, which is a valid colour, but in the dictionary it's all one word, so that's what I do. So forest green will end up as forest green, which is how to find it in the dictionary. So if the colour is in the named colours, you set it to that colour. Otherwise I just say, or the computer says, invalid colour. And as before, it has a bit of a sleep, so it doesn't say invalid colour, say. And then if it didn't understand anything, it says I didn't get that. So that is about it. So I'll just run this.
Say colour or traffic light, then the colour or traffic light command.
I don't know whether you can hear that.
Sorry, I didn't get that. Or traffic light, then the colour or traffic light command.
Right, so this is my dictionary. I just expand it to show you. You have all sorts of things like Alice blue, antique white, azure, beige, chartreuse, and as you can see, they join them all up. So you have dim grey, that wouldn't be very exciting, gold, fuchsia, dodger blue, deep sky blue, yeah, whatever, you get that.
Sorry,
the idea.
I didn't get that. Say colour or traffic light, then the colour or traffic light command.
Colour green.
Say colour
there.
or traffic light, then the colour or
The
traffic
colour
light
is
command.
green. Colour blue.
Invalid colour. Say colour or traffic light, then the colour or traffic light command.
Colour blue.
Say colour or traffic light, then the colour or traffic light command.
Colour fuchsia.
Say colour or traffic light, then the colour or traffic light command.
Colour magenta.
Say colour or traffic light, then the colour or traffic light command.
Colour aqua.
Valid colour.
That
Say
wasn't,
colour or
that's
traffic
my
light, then
fault.
the colour or traffic light command.
Colour forest green.
Say colour or traffic light, then the colour or traffic light command.
Colour orange.
Valid colour. Say colour or traffic light, then the colour or traffic light command.
Colour orange.
Invalid colour. Say colour or traffic light, then the colour or traffic light command.
Colour orange.
Say colour or traffic light, then the colour or traffic light command.
Colour black.
Say colour or traffic light, then the colour or traffic light command.
Traffic light red.
Stop. Say colour or traffic light, then the colour or traffic
I
light
don't know
command.
whether you heard that, but it actually says stop. It didn't say stop very loudly.
Sorry, I didn't get that. Say colour or traffic light, then the colour or traffic light command.
Traffic light go.
Go. Say colour or traffic light, then the colour or traffic light command.
Traffic light amber.
Prepare to stop. Say colour or traffic light, then the colour or traffic light command.
What haven't I done? Traffic light prepare to go.
The traffic light cannot do that.
No.
Say colour or traffic light, then the colour or traffic light command.
Traffic light prepare to go.
Prepare to go. Say colour or traffic light, then the colour or traffic light command.
Quit.
Quitting.
There, that's about all there is to it. I cannot find Alt 2, so I've got to go onto here to